Today's notes are on systems of linear inequalities. The last couple class periods we have been graphing two variable inequalities. Last chapter we did systems of equations. Now we're doing systems of inequalities. So remember these inequalities, sometimes we had dashed lines, sometimes we had solid lines, and then we shaded. System means we're going to have two or more of them together. So starting with a little bit of vocabulary. System of linear inequalities are two or more linear inequalities put together. And then the solution to the system, remember, solution to a system of equations is the point that made both equations true. This is the points, and there's usually going to be more than one, that makes both inequalities true. So the solution of a system of linear inequalities makes each inequality in the system true. So with an inequality, remember, sometimes we had a dashed line and then we shade. So suppose we had a dashed line that looked like that, and then we shade this way. And then we have a system, so we have more than one of these. Maybe our second line looks like this. It's a solid line. And then we shade. The shading looks like this. Remember with the system of equations, we graphed the lines and then we saw where they crossed. We're still doing that. We're graphing and shading and seeing where they cross. And where those two things cross, that's our final answer. So this area right in here, I probably should choose something other than black. This blue area right here is where those two shadings overlap with each other. That's what we'll be looking for. So example 1, we were asked to solve by graphing. Remember, linear inequalities, we only solve them by graphing. It says y is greater than 2x minus 5, and 3x plus 4y is less than 12. Y is greater than 2x minus 5, 3x plus 4y is less than 12. So first inequality, the slope is 2 and the y-intercept is negative 5. It is in slope-intercept form. We start by graphing. So y-intercept is negative 5. Slope is up 2 over 1. We have a dashed line. We don't have the or equal to symbol here, so it is dashed. Maybe. And then we have y is greater than the line. So y is greater than the line tells me the shading needs to be the y values above the line. So we're going to shade in all the y values above the line, which is all these up here. Remember, we're looking for where the two shadings overlap with one another, so that is not my final answer. That's my first inequality. Now we do the second one. The second one is in standard form. You can either change it to slope-intercept form or find the x and the y-intercepts. I'm going to find the x-intercept and the y-intercept. The x-intercept, I put in 0 for y, is going to say 3x equals 12. Solve for x. And I get x equals 4. My x-intercept is 4. We do the same thing for the y-intercept, except now we are plugging in 0 for the x. 0 here gives me positive 4y equals 12. Solve for y. My y-intercept is 3. That'd be good to get another point or two. We can count the slope. It goes down 3 over 4. Down 3 over 4 is off my page, but on this same line I could go up 3, left 4. And that's going to give me another point there. It is a dashed line. And to figure out which way to shade, it is not in slope-intercept form, so we cannot just shade above or below based on what the symbol says. Instead, we use a test point. I'm going to use 0, 0. If I put 0 in for x and 0 in for y, it says 0 plus 0. 0 is less than 12. That is true. 0 is less than 12, so I want to shade in towards 0, 0. Now remember, it was this line right here, so towards 0, 0. So if I shade in towards 0, 0, that's all of this shading down here and over here. And then on a test or quiz, make sure it's very clear where your final answer is. Your final answer is where those two shadings overlap. So I did mine in different colors here. I have the yellow shading, and then I have the blue shading, and the overlaps where it turned to green. So this right in here should be my final answer. So you'd want to shade that in dark or erase the parts that are not part of your final answer. But make sure it's very clear what you indicate your final answer to be. Example 2 is a similar problem. We have y is greater than or equal to negative x plus 2, and 2x plus 4y is less than 4. Y is greater than or equal to negative x plus 2. 2x plus 4y is less than 4. First inequality, slope-intercept form, y-intercept's 2. Slope is negative 1. Negative 1, we're going to write as rise over run. Negative 1, down 1, over 1. We should have a solid line here. And I want the y values greater than that line. Y values greater than that line are going to be the ones above the line. My second inequality, 2x plus 4y is less than 4. My x-intercept, I put in 0 for y. It says 2x equals 4. Solve for x. X-intercept is 2. Get my y-intercept, put in 0 for the x. Solve for y. I get y equals 1. So x equals 2, y equals 1 are my 2 points. I go down 1 over 2, down 1 over 2, down 1 over 2, and continue by going up 1, left 2. This line should be dashed. And it is in standard form, so we cannot just go above or below. We need to plug in a test point. So if I put in 0, 0, this says 0 is less than 4. 0 is less than 4. That's true again. So I want to shade in towards 0, 0. 0, 0 is right here, and I'm on that dashed line, so towards 0, 0 would be this. And hopefully we can recognize where the overlap of the two are. These two things overlap right down, this little overlap right down here. Just 2 examples in the notes today. That's all we've got for the notes. Graph each line, shade each inequality, and then see where those 2 shadings overlap on.